Good morning, good afternoon, or good evening. This is going to be a full walkthrough of the January 2019 4HR paper. As always with these walkthroughs, you should be attempting the paper in its entirety first before using any of this walkthrough. The most value from the question is from you attempting it blind yourself. Without further ado, let's start. Formula page, as always, make sure you're familiar with all the formulas there, and if there is a formula on there you should check it before you use it in a question later on. Question 1. We have a conversion of units. We have the cost in euros and the cost in rubles. To convert that into rubles, we are multiplying by that conversion rate in our calculator. 15,400 multiplied by that 63.21. Now, the question does not give us any rounding. That came out as an exact whole number in my calculator, so I'm going to leave it as such. We have a percentage question now. Express 240 as a percentage of 15,000. Do the division. That'll give us the decimal or the fractional link. Times it by 100 to turn it into a percentage link. Again, in my calculator, that's going to come out as 1.558, and that goes on for quite a while. This time the question did ask us to round to 2 decimal places, so 1.56%. Question 2. We have a square with an area, and the diameter of the circle is the same as the length of the side of a square. Well, a square, if the side lengths are both the same, so that's saying that h squared is 400. So the side length of the square is the square root of 400 is 20. That's the same as the diameter of the circle. But if I'm wanting, I do want the circumference. So because I want the circumference, I'm going to use that diameter. And the circumference is pi d. So 20 pi. We want this to 1 dp. Typing that into our calculator in the SD button to 1 dp, it's 62.8. The units were all centimetres, and I presume centimetres, yeah, it was on the answer line. Question 3. Aeroplane takes 11 hours and 40 minutes, flies a distance of, and we want speed. Remembering our formula, speed is distance over time. Now the problem here is our time is in hours and minutes. 11 hours and 40 minutes. Well, the 40 minutes is 40 out of 60 hours, or 11 and 2/3 of an hour. So that's what I'm going to use in my formula. 9,720 as our distance, divided by 11 and 2/3. Now typing that into our calculator isn't too easy, as we have to use the mixed number option. And that comes out as quite an unpleasant decimal. But it says to the nearest whole number, so 833 kilometers per hour. That seems reasonable for an aeroplane. We're expecting them to be really quite fast. We have the length of a car, and we're having a scale model. Work out the length of the scale model. So we've got a 1 to 20 scale, which is saying that real life is 20 times larger than the model. So going back to the model, That's 20 times smaller. So we're dividing by 20. And we're getting a model length of 23.6 centimeters, which is reasonable for a model. We're also going to make a model of a bus. We have the rate, the length of the real bus compared to the length of the scale model, and we want to find the ratio in 1 to n. So let's set up the ratio first, noticing that we have to convert to the same units. So it's 60 to 1080, dividing by 60 to get it to a 1 to n style ratio. Our calculator tells us that it's 1 to 18. So n is 18. So in this case, the bus is 18 times larger than the model. Algebra. Solve an equation, show clear algebraic working. We want to get the x's on the same side, so I'm going to subtract x from both. It's 4x on the left and the x on the right is gone. Now we undo the layers. Let's get rid of the -2 by adding 2. And then get rid of the 4, the multiply by 4 by dividing by 4 to get our answer 2.5. And remember the trick, if you sub that 2.5 back into the above equation and it works, you know you've got your answer right. Factorize, we're looking for what's common to both terms. There appears to be a t in common, and that's the only thing in common, so we factor that t out. Simplify, with the k there's a hidden power 1. Multiplying, we add the powers, so that's k to the power of 6. On algebraic fractions to simplify, we require a common denominator. The nicest common denominator will be 2h, so I need to double the top and bottom of the second fraction. Then I can subtract the numerators, 3 over 2h. 6, a right angle triangle. We have all the side lengths / want all the side lengths, so this is going to be a Pythagoras. The sum of the squares on the shorter side is equal to the square on the longest. So h squared plus 6 squared equals 9 squared. H squared is then the difference, 81 minus 36. So h squared is 45. Using my calculator to square root that, my calculator tells me simplified third as 3 root 5. Question, however, wants it to 2dp. With the SD button and rounding, you get 6.71 centimeters. Show that fraction question. 2 1/4 times 5, 6. Every time we have fractions, we have to convert to mixed numbers first. 2 1/4, well, I've got 4 quarters in each of the 2's, 8 quarters, and an extra 1. 2 1/4 is 9 quarters times 5 over 6. I like trying to cancel first. I notice there's a common factor of 3 in the 9 and the 6, so I'm going to divide both those by 3. Now I can multiply the tops to get 15, multiply the denominators to get 8, and then the improper back to mixed. There's 1, 8, and 15 with 7 left over. Being a show that I'm not allowed to skip too many steps or just to write it into my calculator. I need to show each of those steps are working clearly. Here is a prism. Find the volume. Volume of a prism is the area of the front multiplied by the length. So my first aim is to try and work out the area of the front of this shape. Now, it's not a standard shape, so we're going to have to cut it into various parts. Now, you could cut down here, or you could cut across. I feel like going down is maybe slightly simpler. So we've got two sections, we've got section A and section B. B is going to be the tough one. Notice the height of the whole shape is 12, and this section here is 5. So the height of my triangle is the leftover. So the height here is 7. Notice also that this length here is the same as the 6 at the back. The whole thing is 10, so that side there is 4. So the area of cross section is going to be the area of A, which is a 12 by 6 rectangle, plus the area of that triangle half base times height. 12 times 6 plus a half of 4 times 7 gives me a cross-sectional area of 86. Then my volume is the cross-sectional area multiplied by the length. So let's multiply that by 25. And we get 2,150 centimeters cubed. Taking a last look at the question, check I haven't messed up any of the units, but everything was in centimeters, and I'm sorted. Question 8. A fraction problem by the look of it. We've bought 120 watches at $50 each. I'm going to not even read the rest. I'm going to glance down what I want to find at the end. I want the percentage profit. So just from that first sentence, I know I'm probably going to need the cost of all of these watches. So 120 multiplied by 50, we spent 6,000 on these watches. That's going to be essential to finding the profit in a second. We sold 3/4 at $80 each. So you've got 3/4 of 120 is 90. So we sold $90, 90 watches at $80 each. So that's going to give me 90 times 80 worth of income. So that's 7,200. From those, we sold the remaining watches at 40 each. So the remaining 40 we sold at, not the remaining 40, the remaining 30 we've sold 90 out of 120 at $40 each. So that gives us another 1,200. So our total income is the sum of those two, 8,400. So our profit is that 8,400. Take away what we paid for them, 2,400 profit. We want the percentage profit. So that is the 2,400 as a percentage of what we paid, the 6,000 times by 100. 2,400 divided by 6,000 times by 100 gives us a 40% profit. Set theory. Our universal set is the numbers from 1 to 10. A is the odd numbers, B are numbers bigger than 6. The U shape is the union. So that's stuff which is in either or both. So list the members. So let's set up our set brackets. We have to have all the odd numbers and the numbers greater than 6. But we're only allowed to go up to what's in the universal set, so we go up to 10. C is the multiples of 3. Members of the set A, N, C. N is and. We're looking for the elements which are in both. Well, 3 is odd and in C, and as is 9. D is a set with 4 members. 5 is in D, and there's no overlap. That line there is saying no overlap with B. Well, to have no overlap with B, I can't have any numbers greater than 6. So I need 4 numbers. 5 has to be one of them, and there are no numbers greater than 6. So let's go 1, 2, 3, 5. is quite a simple possibility there. Lots of combinations for that one, as long as you've got 5 and numbers only less than or equal to 6. A sequence, write an expression in terms of n for the nth term. Well, our first term here is 11, our difference is 10, using the formula that unfortunately we do need to memorize this one, a plus n minus 1 d. That's 11 plus n minus 1 times 10. Now, most of the time you do get the marks without needing to expand out these brackets. I like to try and make things as simple as possible. And that is what I claim to be the nth term. And we can check this. If I sub 1 into this formula, I should get the first term 11. If I sub 2 in, I should get the second term 21, third term sub in 3, get the third term 31, and indeed you do. So you've got a good set of evidence to say we're correct for that. Factorize, we're looking for two numbers which add to -7 and multiply to 6. Well, the only way to add to a negative and multiply to a positive is if they're both negative. So it has to be -1, -6. We'll put them in our brackets. And again, if you're looking for a way to check your working, re-expand those out with FOIL and see if you get the question. Expand and simplify. We're going to FOIL this one. First, we've got a 2e and a 3e, 6e squared. Outside, minus 8ef, another minus 9ef. And the negative times the negative makes 12f squared. We need to simplify now. We can collect together those middle two terms. And nothing more we can do with that. None of those are like terms anymore. Question 12. We're playing netball. We played 11 games. We want to find the interquartile range. Now, glancing across those numbers, it's very unfortunate they are not in order. So the first thing we have to do, and why this is worth 3 marks, not the normal 2, we need to put these in order. So I'm going to start putting them in order. As I do, I'm going to cross off each time I use one. Now, I don't want to cross off too hard that I can't read it again afterwards if I want to check my working. So maybe crossing off in pencil might be smarter. But this is for me to keep track as I go. There's my 237s, I've got 40. Misplanned this slightly and had to go onto a second line. But I believe I've got them all. Another really good way to check if you've got them all, count how many you've got. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we were told there were 11 to start with. Interquartile range for 11. The lower quartile is at 11 plus 1 over 4, is at the third value. Third value is 32. The upper quartile is at 3 lots of that at the 9th value. 1, 2, 3, 4, 5, 6, 7, 8. 9th value is 40. Or equivalently, it's a third value counting from the top downwards. So our interquartile range, do that subtraction, is 8. In February, we played 10. In each of those matches, he scored more than 41 goals. Work out the median of the number of goals that we scored in the 21 matches in January and February. This is quite a nice problem-solving one now. So all of these matches are going to be needing to be put at the end of this list. And we want the median. Well, the median of 21 matches is going to be at the 11th match. Add 1, divide by 2. Well, the 11th match would be, well, it'll have to be that 42. Because we've then got 10 already from January lower than it, all of the February games will be at least 42 or higher. So our median there has to be 42. Quite a nice little logical argument there. We have triangles. Now this question is quite deceiving in what it is. Unless you've revised this recently, you may not recognize straight away that this is a similar triangles question. We have a small triangle at the top, ABC, with side lengths 4 and 5. And we've got the larger triangle, ADE, with a side length there of 7. And that's all we know about ADE. We have been told that ABD and AC are straight lines, and that we've got a parallel condition as well. We want to work out the length of CE, which is just that little section there. Well, I can work out the length of AE using similar triangles. So first up, we need our scale factor. I always go for big divided by small. The 7 and the 4 are the two which match up. So then the length of AE is the smaller side, AC, times by the scale factor. So that's 7 over 4 times 5. 7 over 4 multiplied by 5 gives us 8.75. So CE, which is only the section of that line we need to take away 5, is 3.75. Okay, the second half of this question, of the triangle now. So this looks like we're going to be using scale factor, but area scale factor. Area of the triangle ABC is 8. Well, I can scale that up to find the area of the triangle ADE, but then I want the area of the trapezium. So we're going to have to do a subtraction. So let's first find out the area of ADE. That's a larger triangle, so we're multiplying, and remember when we use area, we're using the scale factor, which is 7 over 4. We need to square the scale factor. So that's 8 multiplied by the 7 over 4 squared, and that gives me my area of 24.5, but that's the area of the entire large triangle. So if I want this trapezium here, I need the area of the large, take away the small, so take away 8 to give 16.5 centimeters squared. Question 14, we're beyond the staples now. Solid shape consists of a cylinder and a hemisphere. The center of the circular face is the same as the cylinder's cross-sectional face. The radius is 10, the height is h, the total surface area. So we're going to have to try and create quite an unpleasant formula to get to this. So I'm going to start by trying to work out the surface area of this shape in terms of h. Now, if we look at the shape, we've got the hemisphere on the top, which is going to be half of the surface area of sphere. Look back to the front page, surface area of sphere is 4 pi r squared. We've got to add on the curved surface area, which is 2 pi r h. Again, that's on the formula sheet at the front. That's your curved surface area, plus the circle at the bottom. I'm going to simplify that a bit because I know r is 10. So the first term is a half times 4 times 10 squared. So that's 200 pi plus 20 pi h plus another 100 pi. So that's 300 pi plus 20 pi h. But the question told us that this surface area is 1,000 pi. Straight away, we've got pi everywhere in this equation, so I'm just going to divide through by pi. I'm going to cancel pi out from everywhere. Then going to subtract the 300. I'm trying to isolate h. And then finally divide by 20. And that gives me a height of my cylinder is 35. Although the picture's not drawn to scale, we can take some hint at h was larger than 10, and being in the same kind of region, 35 seems reasonable. 15. Without even reading the question, we can see it's a tree diagram. We have two counters with some number of red and green in each. We want to complete the probability tree. So on each split, we're splitting red and green, red and green. We need to fill in the probabilities. There are 7 red in A, which is where the 7 over 10 came from. So there are 3 out of 10 in 3 green out of 10 in A. Reading the rest of it, we did take a random counter from A, we did take a random counter from B. There wasn't any swapping of counters. So bag B will always have 4 red, 6 green in both of those situations. So I can fill in all those probabilities as well. We want the probability that we take a red from the first bag and a green from the second. Red, green. So in our picture, we have to go red, green. As we go through our picture, we multiply our probabilities. So that gives us 42 over 100. We should be in the habit of simplifying whenever we can, 21 over 50. There is a part C. Work out the probability at least one red is taken. So to get at least one red, we either do what we've just done and grab a red then a green, or we can take a green and then a red. So we need that possibility as well. So we also need to count the probability of green then red. Probability of green then red is the 3/10 times 4/10, which is 12 over 100, or 6 over 50. I simplified to over 50 so that we can add them more easily. So probability of least one red, well, it's either green red or red green. When we say or in probability, we add the probabilities. So that's 21 over 50 plus the 6 over 50 just calculated. So that's a probability of 27 out of 50. Again, worth checking, does that seem reasonable? The bags were kind of symmetric. One had more red, one had more green. So having a probability around a half doesn't seem ridiculous. Finally, well, next, we've got an inequality. Solve the inequality as so. First thing I'm going to notice is there's a common factor of 2. So I'm going to divide through by 2. Now, notice this is a quadratic inequality, which means we can try and isolate x, but because of the square rooting, we have to be exceptionally careful. Much better for quadratic inequalities is to solve it if it was equal to 0. So factorize and get your 2 values. This is a nice factorization, b in a dots. And then to look at the graph. So this is a quadratic. So it's a U shape that goes through -4 and 4. We want where this is less than 0. So we want the region of the graph where the curve is below the x-axis. So our solution is -4 is less than x is less than 4 to describe that highlighted region. You can do this without a sketch. I wouldn't ever advise it. It makes other things go wrong. Question 17. Circle theorems. AOD is a diameter. BCD is that angle. We want ADB. Well, straight away you notice that ADB is, we can't label it yet. We have to add an extra line in. So let's add that sensible line in. Now ADB is this angle over here that we want. Notice that AOD was a diameter, which means the angle at B has to be a right angle. It does tell us to show a reason. So I'm going to state that fact that DBA equals 90 as angle in a semicircle is 90 degrees. So we use the fact that AOD was a diameter. Let's use the fact that BCD is 112. Well, notice that BCD and BAD are opposite angles in a cyclic quadrilateral. So BAD is 180 minus 112, which gives us an angle of 68 as opposite angles in a cyclic quad add to 180. Well, now look what we've got. We have a triangle where we know two of the angles and we want to know the third. So BDA, I should write it probably the order that they've written in the question, which was ADB, is 180. Take away those other two angles, minus 90, minus 68, says that angle is 22. Even though that was a simple step, we should still give the reason, as angles in a triangle sum to 180. And that's everything I've done, I've given the reason for. Question 18. This looks like, at first glance, a kinematics question. Particle moves along a straight line. The displacement is given by this formula. We want to find an expression for V in terms of t. First thing we should notice is that term there. We can't differentiate it unless it's a power of t. So you first have to rewrite that term. 1 over t is same as t to the power of minus 1. So we've rewritten that, and now we can differentiate it. Remember, in our useful facts, a letter on its own just differentiates to the number in front. T differentiates to 1. Otherwise, we bring down the power. So here we need to multiply by -1, then reduce the power by 1. And any numbers differentiate to nothing. They just disappear completely. We have found an expression for V in terms of t. Find the value of t for which V equals 0. Well, now we just put that expression equal to 0. I'm going to move the 32 to the negative t squared over. I'm also going to rewrite the negative t squared as over t squared. Slightly easier to see the algebra happening. Multiplying up by t squared. So t is the square root, is plus or minus 6. But the question told us that t was greater than 1. So t equals 6 is our answer. You might not get penalized if you forgot the negative root here, but it's worth always remembering. The acceleration is our next part. Well, acceleration is the derivative of velocity. So I need to differentiate again. I'm going to rewrite v down here, so it's right next to our working. So we need to differentiate again. The 1 disappears. Numbers disappear when you differentiate. The second term, we need to bring down the power. We need to multiply by -2 and reduce the power by 1. We want this value when t equals 2. So a is 72 times 2 to the negative 3. Type that in our calculator and it comes out as 9 meters per second squared. Question 19. Simultaneous equations, quadratic and linear. Best way to do these ones is by a substitution. I'm going to label the two equations so I know what I'm looking for and tell the examiner what I'm doing. I'm going to sub 1 into 2. So that's x squared plus, well, instead of y squared now, I'm going to have what y is equals 29. Now it's just algebra. Expand out the brackets carefully, noticing that it is a double bracket and we do get that middle term of minus 16 twice. Collecting everything together on the left hand side, minus 32, and then that's 64. Take away the 29 is a positive 35. I'm going to take a brief moment to think if this does factorize, and indeed it does. You're probably welcome to use a quadratic formula. But I've noticed that 35 is 5 and 7. 5 with 5 makes 25. With the extra 7 can make 32 if I choose everything to be negative. And you can re-expand that to check. So x is either 7 over 5 or 5. We now need the y values, so I'm going to sub into 1. 1 was telling us what y was, so if I sub the 7 over 5 in, 8 minus 2 lots of 7 over 5, I'll get the corresponding y value there, 26 over 5. Or if I sub the other in, 8 minus 2 times 5 gives negative 2. I'm then going to make it really clear to the examiner what my solutions are. So I've got a solution of 7 fifths, 26 fifths, or a solution of 5, negative 2. And if I sub those in and they're correct for both equations, I know I have the answer correctly. Question 20. Find the value of n for which that. Now this is only indices, but it's a very challenging indices question. The only way we can solve these kind of power equations is by making the base number the same everywhere. So I'm going to notice that 4 is 2 squared, 8 is 2 cubed, and 16 is 2 to the power 4 to rewrite this equation. So the equation becomes 2 squared to the power of n, replacing the 4, 2 cubed to the power of n plus 1, replacing the 8, equals 2 to the 4. Simplifying, oh, that's a multiply in the middle, not a plus. Simplifying each of my brackets, a power to a power, we multiply the powers. And I'm also going to multiply that bracket out as well. 3 lots of n plus 1 gives us 3n plus 3, still equals 2 to the 4. Now we're multiplying so we can add the powers. 5n plus 3 equals 2 to the 4. Now we've got the same base number, so now we can just equate the powers. 5n plus 3 equals 4. 5n equals 1, so n is a fifth. And just like with a lot of these solving equations, if I sub a fifth back in, if I type into my calculator 4 to the power of a fifth multiplied by 8 to the power of a fifth plus 1, and if I do that in my calculator quickly, I should get the left hand side, and indeed that does give 16. So this is my little mental check. I have done it right. A fifth was the correct answer. Question 21. A very late histogram question. We'll notice this isn't a complete histogram. It's got a bit more meat to it in a percentage down here. We've collected bamboo plants for an experiment. All the heights are between 10 and 110, so we'll notice our last bar is missing. The incomplete histogram gives some information. We found that 4% of the plants had a height between 90 and 110. Well, another way of saying that 4% were between 90 and 110 is saying that 96% are 10 to 90. And well, we can calculate 10 to 90, so maybe that will help us out. Let's look at each bar, because we're going to have to talk about frequency. So we want the areas of each bar. Now I do this on the picture, but if you want to create yourself a table, a frequency table, to collect this information, you can. Frequency is the area, so that's 10 by 1, so there are 10 plants in there. Our second bar is a base of 20 with a height of 1.7. 20 times 1.7, that has an area of 34. 40 to 70 is a base of 30 times a height of 2 is 60. Base of 20 with a height of 0.8 is 16. So now we have that 96% is, well, the total of what we have there. 10 plus 34 plus 60 plus 16. 96% is 120. So we can work out the total now. This is a reverse percentage question. Total is 120 divided by 0.96. 120 divided by 0.96 says there are 125 plants in total. So that says there are 5 in 90 to 110. Well, that's a base of 20, so frequency density is 5 divided by the class width. 5 divided by 20 is 0.25, so we need to put a final bar over here of height 0.25. This here was a height of 1, so that's height of 0.5, so we're halving that again. So we're going for a bar just there. Probably many other ways to tackle this question. I think this is maybe the simplest. Question 22. A horrendous looking substitution, just algebraic horrendousness. And we also notice this is the last question on the paper. We've got our total marks at the end. So this one we are expecting to fight with. Now we've got a choice. We can sub A, B and C into this expression immediately and try and deal with all of the X stuff. I think it's slightly nicer to try and deal with it in the ABC form first. So I'm going to try it that way. So this is the expression we're trying to deal with. We do not like having fractions in fractions. If we can help it, we should avoid it. So I'm going to multiply top and bottom of this fraction by BC, and that's going to get rid of all of the fractional parts. So I still have my 1 minus, and then be ABC plus C, the B cancelled, over ABC plus B, the C cancelled. Well, now I have two fractions. My answer, notice, is only a single fraction. So I'm going to combine these as a single fraction. So my common denominator is ABC plus B. To make the 1 have that common denominator, we need ABC plus B. Subtract the other one. I put that in a bracket because we're subtracting everything there. Notice the ABC cancels with the ABC. And the numerator just becomes B minus C over ABC plus B. Now that's quite promising. And that's a much nicer expression to sub our stuff into. I'm also going to split my page in half so that I have more working space. I'm actually going to now sub stuff in, but I'm going to do the numerator and denominator separately. and then I'll come back to this right at the end. So the numerator, the top, is b minus c. So that's 3x minus 2 subtract x minus 1 equals, and if I subtract there, 3x minus x, I've got minus 2 minus minus 1, so that's 3x plus 1. So that's minus 2 plus 1 gives us minus 1. The denominator is going to be much less pleasant because we're going to have a triple bracket in the denominator. And I realise I probably don't have a huge amount of space here to do a triple bracket. So the denominator is 2x plus 1 for A, 3x minus 2 for B, x minus 1 for C, and they're adding on an extra 3x minus 2. I'm just going to double check I've quoted each of those correctly. Yeah. Triple bracket, we have to expand 2 at a time and then incorporate the last. So expanding out the first 2, 6x squared, I've got plus 3x, a minus 4x, that was a minus x, minus 2, x minus 1, so it's 3x minus 2. Expanding once again, that gives us 6x cubed from the 6x squared and the x. You've got a minus 6x squared and another minus, so it becomes minus 7x squared. Our x term, we've got minus 2 plus 1. Minus 2 plus 1 is minus x. And we've got a plus 2 on the end, plus 3x minus 2. This is quite pleasant because the 2's cancel. So I'm left with 6x cubed minus 7x. I've got minus x plus 3 plus 2x. And the plus 2 and minus 2 cancel. As with algebraic fractions, we should always be looking to factorize to cancel stuff out. Factorizing here, I've got a common 6. So I've got a common x. And I've lost the squared on that 7x squared plus 2. Now I'm hoping, and if I go back to the question to kind of show why, I'm hoping that this quadratic here factorizes in a way that will cancel the 2x minus 1, which is going to be on the numerator. Because my answer is 1 over. So the 2x minus 1 in the top should cancel. So using that as a hint, I'm just going to predict that this does, and one of the brackets is 2x minus 1. If that was the bracket, the other bracket, that'd be a 3x to kill the 6x squared, minus 2 to make the plus 2 on the end. And if I re-expand this out, I get a minus 3x in the middle and minus 4x on the outside, which does give me the minus 7x in the middle. So yes, this is a correct factorization. So I'm going to go back now to the expression and put in what I've just worked out. So the numerator is 2x minus 1, denominator is x, 2x minus 1, 3x minus 2. I've gone outside the box, which you shouldn't really do. And now notice that we've got the same fraction on the top, factor on the top as the denominator. So it's now 1 over x, 3x minus 2. And notice the question did want it expanded out, so I'm going to re-expand there, 3x squared minus 2x. And I have put that in the required form. That is my answer. Sometimes I like to just tell the examiner really explicitly what I've found out. So for their answer, they had px squared. I have 3x squared, so p is 3. They have plus qx. I've got minus 2x, so q is minus 2. A very, not necessarily challenging question, but you have to be exceptionally careful. You have to be exceptionally accurate with all of your algebra. And by making some of these choices to do the simplifying with ABC first, and then to simplify the top and the bottom separately helps out in this question to keep your answer clear and on track. That was the January 2019 4HR paper. As always, if you have any questions or spotted any mistakes, please do contact me and I'll look to make those corrections. Otherwise, take care. Goodbye.